and welcome to Cherry Pie Math. This video is going to go over drawing triangles and also how to classify them and just different features of triangles in general. So before we get started, I just want you to think, what do you think is the coolest feature of a triangle? My favorite feature is that if you add two sides, it will always be bigger than the third side. I don't know why, I think that's really cool. Maybe your favorite feature is that all the angles add up to 180 every single time. So just take a minute and think about, like, what do you like about triangles? Why do you think they're so cool? So a triangle, by definition, though, is a three-sided figure. Actually, I'm going to write a three-sided enclosed figure with three vertices connecting the three sides. So for example, like this is this obviously it wouldn't be a side, right? This is like a wavy line. So maybe I'll edit this even more. On a three-sided enclosed figure with three vertices connecting the three sides, which are lines. And the reason I'm getting so specific about it is because in geometry, and I learned this the hard way in college, that they're so specific about the different ways to write the shapes. Like, you're like, oh, a square has four sides. Well, guess what, buddy? There's 6 million things that have four sides. You got to be more specific than that. So we want to be as specific as we can be. But at the end of the day, a triangle has 3 points, basically, and then it's made by connecting the 3 points. That's how you would define, like, a triangle. It's 3 points, and then you connect the 3 points with lines, and you get a triangle out of it. There are different ways to classify triangles. There's the sides way and there's the angles way, and you can usually pick one from each column, I guess, because they have 3 sides and 3 angles. So when we're classifying triangles with sides, the equilateral triangles means all sides are congruent, and this is a fancy word that just means the same length and size. But we use it a lot in geometry. So all sides are congruent. In an isosceles triangle, 2 sides are congruent, but the third side is not. And then in a scaling triangle, no sides are congruent. All 3 of them are different sizes. Okay, so that's in terms of sides. And then we have angles. A right triangle is one with one right angle. We actually can't have more than one because then it wouldn't be a triangle. Triangles have to have a sum of 180 degrees. But the problem is, if you have one angle that's already 90 degrees, if you try to have the other one be 90 degrees too, they will never connect, right? So to be a right triangle, only one of them can be 90 degrees because then it would just be a line, or it would be a disconnected triangle at that point. An acute triangle means all angles are less than 90 degrees because acute means less than 90 degrees. An obtuse triangle means one angle is more than 90 degrees. And again, kind of the same reasoning as the right triangle. You can't have more than one obtuse angle because then it wouldn't be a triangle anymore. There's that limit at 180 degrees per triangle. And so if you have something bigger than 90 degrees, you can't have another thing bigger than 90 degrees because 90 plus 90 is 180. And so if you add anything else than that, it's going to go over 180 degrees and it wouldn't be a triangle anymore. So you can only ever have one right and one obtuse angle. So if I was to make a triangle like this, actually, we'll just talk about that on the next slide because I have a thing for that. So they do overlap. You have one from each column, and like isosceles triangles and equilateral triangles both have at least 2 sides, but you're looking for the most amount of it is. So like an equilateral triangle is also technically kind of an isosceles triangle, but it's more an equilateral triangle because you have all 3 sides, right? So if I was to make this triangle here, and I said these two sides are equal or congruent, but that side isn't, this would be an isosceles triangle. And it would be an acute isosceles triangle because all the angles are less than 90 degrees. Or like if I drew this one, this, we'll call each of these a different size length. Those tick marks mean that everything with the same amount of tick marks is congruent. So like in the isosceles triangle, these two sides were congruent because they both have one tick mark. But in this one, all the sides have a different amount of tick marks, so they're all different sizes. So this would be scalene in terms of the sides because the three sides are different sizes. And this would be obtuse. This would be an obtuse scalene triangle because this one is larger than 90 degrees. And like I said before, you can only ever have one angle that's greater than 90 degrees. And then there's different features of all triangles. So there's three sides, obviously. There's three angles. Another big thing is that the interior angle sum, try to say that 5 times fast, means that all interior angles, so all the angles on the inside, add up to 180 degrees. Up to 180 degrees. And this is a super useful just fact, at least in Euclidean geometry, which is the one that we're using, because you can do a lot of cool algebra with this, and trying to figure out if this is 180 degrees, if we know that triangles add up to 180 degrees and lines have 180 degrees, and you just kind of mix them up and it gets really cool. But that's a really important fact that you should not forget until, honestly, ever, because you probably will even use it when you're doing like home improvement or whatever. And the last one, the triangle inequality theorem, this is the one that I really like. It says that two sides together will always be greater than the third side. And it doesn't matter which two you pick, it will always be the case. If you add two sides together and it's less than the third side, then that triangle is impossible. So let's take a look at some different scenarios and make sure that they would be triangles. So for example, side lengths 5, 7, and 9. We don't know anything about the angles, but we can use the triangle inequality theorem, like I said here, where with the two sides greater than the third side. So let's check. 5 plus 7 equals 12. 12 is greater than 9, so check. 5 plus 9 is equal to 14. That's greater than 7, check. And 7 plus 9 is equal to 16. That's greater than 5, check. So yes, this would be a triangle. It would probably look like, let's say this is 5, and then this is 7, and this would be 9 or something like that. It's not super exact, but you can pretend. Triangle 2, let's try again. So we have 2 plus 6, that's equal to 8. Wait a minute, 8 is less than 10. This does not work because it fails the triangle inequality theorem. You cannot have two sides added and have it be less than the third side. It has to be greater than the third side. And then let's try this last one. So 29, 48, and 103. We know that if we add them together, it should be 180 degrees exactly. So let's try it. So 29 plus 48 would be 77, right? And then we would add 103, and that is equal to 180. Check. This would be a triangle, and I'm going to just pretend like this is going to be 29 degrees. That's too big to be 29 degrees. 29 degrees, and that's this is 103 degrees, and then this would be like 48 degrees-ish. It would kind of look something like this. It's not exact. You can use the computer to make it more exact. Okay, so let's try drawing one. We know that one side is 4 centimeters, so I don't have a ruler on me, but I mean, hopefully if you're watching this, you get the gist of it anyway. So we're going to call this 4 centimeters. We know that the angle on the left is 55 degrees, so I want to make a 55-degree angle, and then to draw that, I'm using my protractor, and I'm going to zoom in here. You would put a dot here in the middle and make a line just to start off. This is 0 degrees on this particular protractor. And then if I wanted, what was it, 55 degrees? So 55 degrees is right here. So I'm going to draw a line that connects those. There we go. And then I'm going to copy this one and bring it down here. Okay, so I know that that angle is 55 degrees. That takes care of one side. And I know I want to do the other side as well. The other side would be 65 degrees. And since it's facing the other way, I'm just going to do it the opposite direction of what I just did. So there's my baseline, and then I want it at 65. Let's try that again. I want to make my lines pretty. There we go. And then I'm going to copy this down. I'm going to put that on the other end, and I know that this is 65 degrees. And I see that they connect right here. So that would be my triangle. This triangle has a 4 centimeter base. It has 55 degrees on one side and 65 degrees on the other side. And there's no other possible triangles that I can make out of this. So part of the Utah core is that they also want you to be able to do this on the computer. So we're going to be using Geogebra. I just went to geogebra.com/calculator, and we're going to do this on a graphing calculator. So I press tools, and I'm going to do the same triangle as before. So first I want to start with that segment of given length 4. So I pressed at 0, 0, and I wrote 4. I got this awesome segment out of it. And I know that I want to make 2 angles, one on the left side and one on the right side. So I'm going to scroll until I find angle with given size right there. I'm going to click that, and then I'm going to press B and then A and then write 55 degrees and make sure that it's counterclockwise, because that's the direction that I want it going. The reason I do B and then A is because A is going to be in the middle, and then B is kind of like where my starting line went. And so I'm going to do that again on the other side in just a bit. So first I make a ray so that I have that line for reference later. And now I'm going to go back and I'm going to do the same thing on the other side, except A and then B in this case, because I want B to be my vertex. And I'm also going to make sure that it's clockwise so that it heads the other direction, so that it heads above the x-axis. And then I make another ray from B to A prime in this case. And you can kind of see that those 2 lines cross very close to that. And it's kind of hard to see it from right here. I can't move these points. Those are fixed just because the GeoGebra just wanted me to be able to see where that ray would end up. So if I zoom in real close here, then I scroll over, I can see where they intersect. So I can just put a point right there. And then if I zoom out, I have basically the same kind of triangle that I had just drawn with my ruler and my protractor. And so that's how you would make it if you were going to do it on GeoGebra. Let's do one more example. We're going to make a triangle with a segment of 7, a segment of 5, and then on this, they're connected, but on the open end of the 7, we're going to put an angle of 40 degrees. So kind of like before, I start with that segment of 7, and then I'm going to make another segment of 5, both starting at A because that's where they're connected. I'm going to move that segment of C out of the way. Sorry, there was that thing in the bottom there. I'm going to move that C out of the way and worry about it later. That's my length of 5. You can see that it lines up real nice. And then I'm going to make that angle with a given size because I want it to be 40 degrees again. So I do A and then B because I want my angle at B. I make sure that it's clockwise so that it's headed upwards. In this case, we want the angle to start on the x-axis and head upwards. I'm going to make my ray like before. So it's going from B to A prime. And then I'm going to get my point C and I'm going to move it around to see where I can put it. And there's actually 2 places. I could end it up here, and that would be a triangle with this fulfilling the given conditions. But I can also move it down here and I would still have another triangle with the same conditions. And so there's actually 2 different ways I could have made a triangle in this case. And it's cool to see that with that technology. Okay, so some things to remember is that you can have classifications in both sides and angles, and you should be able to get one from each category. The angles have to add up to 180 degrees. It can't be more, it can't be less. In Euclidean geometry, it has to be exactly 180 degrees. Sometimes you can make more than one triangle with the same given information. And then I recommend when you're drawing just to start with your base side and an angle so that you can build off of that. And it just kind of gives you a nice place to build. Okay, I hope that helps and good luck.